Hello to everyone. In this chapter, we are going to see about a 9th standard science, chemical bonding. The last session we had seen about a Kozal and Lewis electronic theory of valency and how the electrons are shared and the bonds are formed. We had seen that. In this chapter, we are going to see about types of chemical bond. Before that, we came to know what is valence shell electrons. So outermost electron that is present in the element. Outermost shell of an element contains some electrons. That electrons are called as a valence shell electrons. So every element have a different valence shell electrons, as we saw before. Sodium and chlorine, the formation of a sodium ion and chlorine ion, we had seen. Sodium has a electronic configuration of a 2, 8, 1 and chlorine has a electronic configuration of 2, 8, 7. So in the same way, all the elements have a different valence shell electronic configuration. So depending upon these valence shell electrons, bond formed between the two elements to form a compound also differs. So there are different types of chemical bond. So there are mainly three type of chemical bond. That is a ionic bond, uncovalent bond, coordinate bond. These three bonds we are going to see in this chapter. And other type of bond we will study in the higher classes. The first one we are now going to see is ionic or electrovalent bond. Let us move on to that. What is ionic bond? An ionic bond is a chemical bond formed by the electrostatic attraction between the positive and negative ions. How the element become positive and negative ion? Listen, a sodium atom consists of electrons in the configuration of 2, 8, 1. As we saw earlier, this sodium atom tends to lose one electron in order to attain the inert gas configuration of a neon, that is 2, 8. So if it loses one electron, then the sodium atom will become a sodium ion, Na+. Sodium atom Na is a symbol of sodium. It will become a Na+ by losing an electron. So thus the positive ions are formed. By losing an electron, positive ions will form. How negative ions will form? The answer is, we know that chloride ion has a electronic configuration of 2, 8, 7. It needs one electron to attain the electronic configuration of an inert gas argon, that is 2, 8, 8. 2, 8, 7 is electron configuration of chlorine and it needs one more electron. So it receives the electron and becomes a negative ion. Okay, so if an atom loses an electron, it will become a positive ion. If an atom gains an electron, it will become a negative ion. So these positive and negative ions had a bond between them. That bond is called ionic bond, and it is because of the electrostatic attraction between the positive and negative ions. There is some attraction between these two atoms. There is a positive atom, positive ion. Sorry, it is not an atom, it is an ion. Positive ion and negative ion. And this electrostatic attraction is responsible for the formation of a bond. That bond is called as ionic bond. So ionic bond is a chemical bond formed by the electrostatic attraction between the positive and negative ions. So this bond is formed between the two atoms when one or more electrons are transferred from valence shell of one atom to valence shell of another atom. So here atom 1 donates one electron, and it becomes positive ion because it donates an electron. So atom 1 becomes a positive ion, and atom 2 receives an electron from atom 1. So atom 2 becomes a negative ion because it receives an electron from atom 1. So these two atoms receives one electron and loses one electron. So thus the bond is formed due to the electrostatic attraction. So the atom that loses electrons will form a cation. The positive ion is otherwise called as cation. Atom which loses an electron is called as a cation. In other words, it's a positive ion. And the atom which gains an electron, it's called as anion. That is a negative ion. So these oppositely charged ions come close to each other due to electrostatic force of attraction, or thus form an ionic bond. So the electrostatic force is formed because of these two atoms are entirely oppositely charged. One is positive, another is a negative. So they attract each other. So thus a bond is formed. That bond is called as ionic bond. So it is otherwise called as electrostatic bond. Electrostatic bond is another name for ionic bond. It's also called as electrovalent bond. So three names are there for ionic bond. One is ionic bond. Second one is a electrostatic bond because the force exists between this is electrostatic force of attraction. So it is also called as electrostatic bond. And third bond name is electrovalent bond. So these three names are common for ionic bond. Ionic bond, electrostatic bond and electrovalent bond. Okay. Let us move on to the formation of ionic bond. Let me explain how this ionic bond is formed. So let us consider two atoms, A and B. So A atom has a 1 electron in excess, and atom B has 1 electron lesser than the stable octet electronic configuration. So atom A consists of a 1 atom extra. So by losing this electron, it will become a stable inert gas configuration, that is octet rule. It comes under octet rule. The same way the atom B has 1 electron less to attain the stable inert gas configuration. So what will be there? Atom A will donate an electron, atom B will receive an electron. So this and by losing the electron, atom A become a positive charged ion, that is a cation, and by gaining an electron, atom B becomes negatively charged ion, that is an anion. So these oppositely charged ions are held together by electrostatic force of attraction, which is called as ionic bond. So hope you understand that how this ionic bond is formed. Simply atom A, atom B. Atom A has a 1 electron excess in it, and atom B has a 1 electron lesser than that. So this 2 electron, one loses an electron and one gains an electron. By losing an electron, atom A becomes a positively charged and atom B becomes a negatively charged ion. Oh, that's a bond is formed between them because these two are oppositely charged, and this bond is called as ionic bond. So what type of element the ionic bond will form? Ionic bond is formed by what type of elements? Ionic bond is normally formed between a metal and a non-metal. Here two atoms are there, you know that atoms will be, one atom will be a metal and another atom will be a non-metal. Probably the compounds containing ionic bonds are called ionic compounds. In the periodic table, group 1 and group 2, that is if you are seeing the periodic chart, the first vertical column and second vertical column, they are called as group 1 and group 2. And they are termed as group 1 is alkali metals and group 2 is alkaline earth metals. So these metals probably form the ionic bond when they react with the non-metals. Non-metals are probably present in the 14th, 15th, 16th group of a periodic table. So these first and second group elements, that is alkali metals and alkaline metals, these metals probably form an ionic bond when it combined with the non-metals. So ionic bond contains one metal and one non-metal. Okay, let me explain now how the ionic bond is formed in sodium chloride. Sodium chloride. Okay, listen. The atomic number of sodium is 11. That is a total number of electrons present in a sodium is 11, and it is arranged as in the shell as 2, 8, 1. That is, a first shell consists of 2 electrons, second shell consists of 8 electrons, and third shell consists of 1 electron. So sodium atom tends to attain the electronic configuration of a inert gas of neon, that is 2, 8. So it wants to lose an electron. One electron is excessively present in it. So it wants to lose an electron. So it donates 1 electron. Okay. So by losing the 1 electron, the sodium atom will become a sodium ion, that is Na+. See in the picture, it's clearly given. The same way, another atom that is present in sodium chloride is chlorine. It is a non-metal. We can find the chlorine in a 17th group in the periodic table. It's a halogen. It is a non-metal. So the atomic number of chlorine is 17. 17 means the electrons is arranged. The total number of electrons present in a chlorine is 17. And the electronic configuration is, the electron is arranged in 2, 8, 7. It has a 1 electron less to the nearest stable electronic configuration of noble gas, argon. See, the first shell consists of 2 electrons, second shell consists of 8 electrons, a third shell consists of 7 electrons. So, in order to attain the octet rule, that is 8 electrons in its outermost shell, it needs 1 more electron to attain the stable inert gas configuration of argon. So, chlorine has a tendency to gain 1 electron to acquire the stable electronic configuration. That it gains an electron and it becomes a negatively charged ion, that is an anion, Cl-. Okay, you can see in the picture, that is a sodium gives an electron to chlorine because it has a tendency to lose an electron and it becomes a Na+ ion. And chlorine gains 1 electron to attain the stable electronic configuration of argon. So it receives an electron from a sodium and it becomes a 2, 8, 8. So chlorine becomes Cl-. So now sodium atom becomes sodium ion, Na+ cation, and chlorine atom becomes chloride ion, negative anion. So being the 2 atoms are positively charged and negatively charged, there is totally different charged particles, they attract each other. That attraction is called as an electrostatic force of attraction, and thus the bond is formed, and this bond is called as electrovalent bond, that is ionic bond. So this is a way that ionic bond is formed in a sodium chloride salt. Sodium chloride is nothing but a common salt that we are using in your day-to-day life, cooking purpose, table salt. Okay. So next example is a formation of ionic bond in magnesium chloride, MgCl2. Here the atomic number of a magnesium is 12. Electronic configuration is 2, 8, 2. Magnesium has electronic configuration of 2, 8, 2. That is, the first shell consists of 2 electrons, second shell consists of 8 electrons, and third shell consists of 2 electrons. And this magnesium contains 2 excess electrons. So it has tendency to lose an electron to attain the inert gas configuration of a neon, that is 2, 8. It does not need 2 electrons. It wants to donate an electron to another non-metal. What is non-metal attached with it is chlorine. Here 2 chlorine atoms are present. The formula is MgCl2. As we saw earlier in the sodium chloride bond formation, chlorine has a 1 electrons lesser to attain the stable electronic configuration of argon. Here 2 chlorine atom is present. So 1 electron need for one atom of chlorine and another electron need for a second chlorine atom. So totally 2 electron will be need for a chlorine atom to attain the nearest electronic configuration of inert gases argon, that is 2, 8, 8. Watch carefully. Magnesium has a 2 electron excess in it, that is 2, 8, 2. 2 electron lost shell consists of 2 electrons. It wants to lose these 2 electrons. And chlorine atom, 1 chlorine atom wants 1 electron to it, and another chlorine atom, that is chlorine 2 atom, wants a single electron from a magnesium to fulfill its octet condition. And so totally 2 electrons will be needed by the Cl2 molecules. So these loss of 2 electrons from magnesium will go to 1 electron will go to chlorine 1 atom and 1 electron will go to chlorine 2 atom as shown in the figure. So by losing a 2 electron, magnesium becomes Mg plus ion, and by gaining 1 electron by 1 chlorine and another electron by another chlorine atom, it also becomes a negative charged particle, that is an anion. So by losing an electron, Mg becomes Mg plus cation, and by gaining an electron, Cl2 becomes Cl2 minus ion, that is an anion. So thus a bond is formed because this totally different charged particles is present, that is Mg plus and Cl2 minus. So the bond is formed between the different charged particles. That bond is called as a ionic bond. Hope you understand that. Yes. So let us move on to properties of a ionic bond. How the physical state of ionic bond is. The compounds are formed because a strong electrostatic force between the cation and ion, which are arranged in a well-defined geometrical pattern. So the ionic compounds are crystalline solids at room temperature. So they have a strong electrostatic force of attraction between the cation and anion. Say for example sodium chloride, you can see the table salt in your home. It's a crystalline white solid, and it is a shiny one, and it has a well-defined geometrical pattern inside it. So these compounds are crystalline solids at room temperature. This crystalline is nothing but the picture that you are seeing in your screen. This crystalline nature is because of the strong electrostatic force between the cation and anion. In sodium chloride, Na plus is a cation and Cl minus is anion. These two charged particles have a strong electrostatic force of attraction between them, that it becomes a crystalline nature. So physical state is crystalline nature at room temperature. So second one is electrical conductivity. Will the ionic compounds conduct electricity? No, ionic compounds does not conduct electricity because it is in a crystalline solids. A strong, tight electrostatic force of attraction are held together. They are tightly bonded, so they cannot move freely. So in a solid state, it does not conduct electricity. Whereas if you are dissolving it in a liquid, there is a water, it will conduct electricity. See the common salt, sodium chloride, whether it's a solid state, it does not conduct electricity. But we are dissolving the salt in a water, it will conduct electricity. So electrical conductivity is there when the solid is dissolved. Then only it conducts electricity. In a solid state, it does not conduct electricity. Yes. Next one is a melting point. Since the electrostatic force of attraction between the cations and ions are strong, it holds tightly, very high energy is required to separate them. Strong force of attraction is existing between the bond is very strong between the positive and negative ion. So we need more energy to break the bond. Hence ionic compounds have a high melting and boiling point. You should know what is melting point and what is boiling point. Melting point is applicable only to solids. The state at which the temperature at which the solid get liquid. If you are saying melting of ice cubes will become a liquid water. So state at which the temperature at which the ice cubes will become a liquid water is called as a melting point of ice. That is 0 degrees Celsius. The same way, every solid substance have a definite melting point. So if you are heating the table salt, that is a sodium chloride, that we are using so many of salt in our home for cooking purpose. If you are heating the salt, a temperature at which this salt will become a liquid, that is the melting point of that particular salt. In the same way, the boiling point is applicable only to the liquids. A temperature at which begin to boil, the bubbles will come. It will begin to evaporate. That temperature is called as boiling point. So probably these ionic compounds have a higher melting and boiling point because a strong electrostatic force of attraction is there between the cation and anion. The bond is very strong. Okay. Next one is the solubility. Ionic compounds are soluble in polar solvents. We all know that. We have seen in our home itself the table salt. It will dissolve in water. So it will dissolve. Ionic compounds are soluble in water and it does not get dissolved in non-polar solvents. Solvent is a thing which dissolves the substance. So there are some substances in chemical nature, there is a benzene, carbon tetrachlorides have some of the solvent that will dissolve substances like a fat and some other chemical substances. So this ionic substances does not get dissolved in this kind of solvent. It will dissolve only in water. What about density, hardness and brittleness? Ionic compounds have a high density, they are quite hard. They are high density and quite hard. Because of the strong electrostatic force of attraction, they are highly brittle. What do you mean by brittle? Easy to break. Brittle. Easy to break. And it has a high density and quite hard. It looks like hard, but it will brittle. See, if you are seeing the preparation of sodium chloride in the salt industries, it's a very big stone-like structure. And afterwards we can break it. That's the nature of ionic compound. It's hard, but it can be brittle one. It can be easily breakable one. And last one is a reaction. How the ionic compound reacts அப்படின்னா, ionic compounds undergo ionic reaction which are particularly rapid and instantaneous. It's react very fastly. Very rapidly it will react with the other elements. So this is a thing that we saw under the properties of a ionic compound. Hope you understand this. We will see the covalent bond and its properties in the next session. Thank you.